Hi friends. In this lecture, we are going to learn about the insertion of a new node at the end of a linked list. We already discussed about how we can insert a new node at the beginning of a linked list. Now we have to insert a new node at the end of the linked list. And yes, you guessed right that for that we need to traverse the entire linked list so as we need to end to the end of the linked list. So we have here a pointer containing the address of our first node, that is the head. I'm sorry, it would contain definitely the address actually, the address of our first node. Okay, let's say this is our first node. Okay, I'm using the same example as I used earlier. Just for simplicity, I'm placing the data and the pointer addresses. Okay, let's say it is null. Why? Because there is no node ahead of this, and this is our last node. Okay, not the end, this is the last node of the linked list. Okay, and this is, of course, our head pointer that is pointing to the very first node and it contains the address of the first node. Okay, so this is our single linked list, and our requirement is we need to insert a new node at the end of the list. That means here. Now we need to insert this, so we can't just go to the end directly because I have already told that the in order to access any node in a linked list, we need to have a sequential access. And when the term sequential comes, that means we need to traverse down up to the end. Okay, so let's now focus on the function to insert the node at the end. Insert at end. Of course, for this function, we are going to provide the head pointer, which is of type node. Then here we are going to have one pointer, one node pointer to, of course, for traversal, and one other node pointer temp that will contain the address of the newly created node. Okay, so these are the basic requirements. Now let's begin by creating a new node, and as I already said that for creating we need to allocate some memory space to this new node. So node pointer malloc size of node. So we are allocating the size of node space and providing the address to this temp variable. Okay, so this is the creation. Now we are going to provide the data for this newly created node. Okay, and printf enter, I can take data from the user, enter the data, and then we have the scanner for getting the data from the user. Okay, now we have the data and our node is ready. Okay, so this way we have got the new node. Okay, node creation is done, and we have our new node here, and the temp will contain the address of the newly created node. This is the temp, right? Let's say it is 500. Okay, here we have put the null, and let's say here we have put 40. Okay, so this is our new node. This we have to insert at the end of the linked list. Hence, we need to traverse down till the end. Okay. So, okay. Now we need this queue for the traverser. So while, okay, the first thing that we need to check here that whether our linked list is empty or not. This is the very first check we have been doing since beginning. So if head equal to, or simply we can say that, yeah, if head equal to null, uh, then definitely we have a zero element or zero node in the linked list, and this will be our first node. Then we need to provide the address of the new node to head, and that's all done, right? But if are already some elements in our linked list, like we have seen in our example, then of course we need to traverse down till the end. So we are providing the first node address to our node pointer q, and then we are traversing down till the end while next of q not equal to null. Okay, till that we are going to keep on incrementing the queue, right? Now as soon as we reach here, that is when next of q is null, that is we have reached at the end of the linked list. Then what we'll do, we will update the pointers. Okay, so we'll place in the next of the queue, we'll place the temp. Okay, and we can make temp equal to null. Now temp we are not requiring, and it's optional, you can do or not. This is just a memory location address for the newly created node. But now we have attached the node to the end of our linked list here. So this node now, this up, instead of null we have updated it to 500, right? So now this points to our newly created node. So this link is unnecessary, right? So this is our last node with the null pointer. Okay, so that's it. And we will come out of this, and this is our function. Very simple code. Just the traverser is needed if we want to attach a new node at the end of the linked list, right? First, we are checking if the linked list is empty or not. If it is empty, then the very first node is the only node, the created node is only the node of our linked list. So we are pointing the head to the newly created node. Else, if we have one or more than one node in our linked list, then definitely we have to go up till we are getting the null pointer in the next of the node, and there we will attach our new created node and update the pointer, and will come out, and then we will have our linked list ready. Okay, this is the node creation state that we have already seen, how we create the new node. So that's it. It's simple and easy. We can implement this in any language. Okay. So that's the end of the video. We will be looking for the insertion of new node at any specific position in the linked list in the later videos. Keep watching, and thank you very much for your patience.